Hello, how are you? Welcome to the CurioClips channel. For 0.6 billion years ago, Earth was just a small speck of dust floating around in space. Today, it's the only planet we know of that has life on it. So how did Earth go from a tiny speck to a thriving oasis? Keep watching to find out. This is the story of how Earth was formed, from cosmic dust to our home. For 0.6 billion years ago, Earth didn't exist. Instead, it was just a small speck of dust floating around in space. This dust cloud seemed ordinary, but over billions of years, it would be transformed into the planet we call home. The Earth's formation began when gravity caused a huge cloud of dust and gas to collapse. This dust cloud was made up of mostly hydrogen and helium, with trace amounts of other elements such as oxygen, carbon, and iron. As the cloud collapsed, it began to spin and take on a disc-like shape. The center of the disk became denser and hotter, forming a protostar that would eventually become our sun. At the same time, the remaining material in the disk clung together in growing clumps, forming pebbles, then rocks, and eventually larger bodies. These bodies continued to grow, attracting more and more material until they became protoplanets. Earth wasn't the only protoplanet. In fact, there were many others, some much larger than Earth. These protoplanets seemed destined to stay that way forever, locked in an eternal struggle to gain enough mass to become full-fledged planets. But then something unexpected happened. One of the protoplanets, which scientists believe was about 5 times the size of Earth, crashed into Earth. This giant impact was the turning point in Earth's formation. Before the impact, Earth was a small, cool, and rocky world, not much larger than the Moon. But the crash brought huge amounts of new material to Earth's surface, causing its radius to expand by more than 1,000 kilometers. This brought Earth closer to its present size, but it also had other effects. The impact heated Earth's core, melting much of the rock and allowing heavier elements such as iron and nickel to sink to the center. This process, known as differentiation, led to the formation of Earth's core, mantle, and crust. But the core didn't just sit there. It began to spin, powered by the energy released during the giant impact. This spinning core generated a magnetic field that shielded Earth from the deadly radiation of the sun. The magnetic field also caused the atmosphere to expand, forming a protective bubble around the planet. Thanks to the giant impact, Earth was now larger, hotter, and more hospitable to life than ever before. But despite all these changes, Earth was still not ready to be the home of complex life. You see, the atmosphere didn't just protect Earth from the sun, it also trapped heat, causing the planet to become incredibly hot. This wouldn't have been a problem if Earth's surface hadn't been bombarded by asteroids and comets. These impacts vaporized water on the surface and released large amounts of carbon dioxide into the atmosphere. The result was a runaway greenhouse effect that made Earth a hot, uninhabitable world. But then something incredible happened. A series of massive volcanic eruptions released even more carbon dioxide into the atmosphere, causing the greenhouse effect to go into overdrive. Temperatures rose to as much as 350 degrees Celsius, hot enough to melt lead. But don't forget the oceans. Thanks to Earth's magnetic field, the surface temperature of the ocean was much cooler than that of the land. In shallow areas, it was possible for liquid water to exist. And in deeper waters, it was cold enough for water to freeze, forming huge ice sheets. These conditions lasted for hundreds of millions of years, shaping Earth's surface and creating the first continents. But the intense volcanic activity also had another effect. It released huge amounts of oxygen into the atmosphere. At first, this oxygen combined with other elements, forming new compounds and making it hard for life to emerge. But eventually, the reaction slowed down and Earth's atmosphere began to look more like the one we have today, with enough free oxygen to support the first simple life forms. It took another billion years for complex life to appear, perhaps because the formation of the ozone layer, which filters out harmful ultraviolet radiation from the sun, allowed for life to flourish. But once it did flourish, Earth exploded with an array of living things. Fish appeared 500 million years ago, followed by amphibians, reptiles, and eventually mammals. Dinosaurs ruled the Earth for more than 100 million years, but then they went extinct, opening the door for mammals to take over. And then, about 300,000 years ago, something truly remarkable happened. Humans emerged on the scene and quickly became the dominant species on Earth. But that's not where the story ends. Although Earth has changed dramatically over the past 4.6 billion years, it's still constantly evolving. The continents are still moving, the climate is still changing, and new species are still emerging. For example, scientists have discovered evidence of at least 6 mass extinctions in Earth's past, each followed by a recovery and a burst of new life. Will humans play a role in shaping Earth's future, or will we be remembered as just another chapter in the planet's long history? In the early days of Earth's formation, the planet was bombarded by asteroids and comets, leaving craters and scars across its surface. But over time, these features have been worn away by geological processes such as erosion and plate tectonics. Today, the only visible evidence of these impacts is a small number of craters, such as the Barringer crater in Arizona and the Chesapeake Bay in Virginia. But it wasn't just asteroids and comets that shaped Earth's surface. Volcanoes also played a major role. In the past, there were many more volcanoes on Earth than there are today, and they were often much larger and more active. The remnants of these ancient volcanoes can be found all over the world, such as Mount Everest and Mount Kilimanjaro. But perhaps the most significant change to Earth's surface has been the formation of the continents. Originally, Earth was a hot, bumpy world without any true continents. But as the planet cooled, the rock hardened and the continents began to form. The continents moved around for hundreds of millions of years, sometimes joining together to form supercontinents. But today, they have formed a pattern that has remained relatively stable for more than 100 million years. Earth's surface is still changing, however, due to plate tectonics. The continents are slowly drifting apart, which is causing the Atlantic Ocean to get wider and the Pacific Ocean to get smaller. But these changes are taking place over millions of years. Compared to the vast timescale of Earth's history, they are essentially instantaneous. Now let's talk about the atmosphere. Earth's first atmosphere was very different from today's. It was thinner, hotter, and more hostile to life. But over time, the atmosphere has changed dramatically. The giant impact that gave Earth its magnetic field also released huge amounts of carbon dioxide into the atmosphere, causing a runaway greenhouse effect. But this effect was eventually stabilized by the formation of the ozone layer, which filtered out harmful radiation from the sun. Today, Earth's atmosphere is mostly made up of nitrogen and oxygen, with trace amounts of other gases. The atmosphere plays a vital role in supporting life on Earth. It provides us with air to breathe, shields us from the sun's radiation, and helps to regulate the climate. But the atmosphere is still changing. Human activities have released huge amounts of carbon dioxide and other greenhouse gases into the atmosphere, causing the climate to warm at an alarming rate. Earth's water cycle has also changed over time. In the past, there were more volcanoes and more water vapor in the atmosphere, which led to more rainfall. But today, human activities have led to deforestation and the construction of dams, which have altered the water cycle and led to water shortages in some areas. Finally, let's discuss the evolution of life on Earth. Life first appeared on Earth about 3.5 billion years ago. Since then, it has undergone some truly remarkable changes. For example, the first multicellular organisms appeared about 600 million years ago, followed by the first animals about 540 million years ago. The dinosaurs ruled the Earth for more than 100 million years, but then they went extinct, opening the door for mammals to take over. Humans emerged on the scene about 300,000 years ago and quickly became the dominant species on Earth. But throughout Earth's history, there have been many mass extinctions. In fact, scientists have identified 6 mass extinctions, each followed by a recovery and a burst of new life. Today, humans are causing their own mass extinction, which may have a profound impact on the future of life on Earth. But no matter what the future holds, one thing is certain: Earth will continue to evolve and change in ways we can only imagine. From a tiny speck of dust to the home of complex life, Earth has come a long way. But its journey is far from over. Will you be part of Earth's next chapter, or will you be remembered as just another page in its vast history book? If you enjoyed learning about the amazing story of how Earth was formed, then be sure to give this video a like and subscribe to our channel for more educational content. And now it's time to hear from you. What do you find most amazing about Earth's story, and how do you think the planet will change in the future? Share your thoughts in the comments below. Thanks for watching, and see you soon.